Hello everyone, I'm Raphaël Poulain, a PhD student at the University of Delaware, and today I will be presenting our work, Few-Shot Learning with Semi-Supervised Transformers for Electronic Health Records. So this work was motivated by a few observations. First, biomedical machine learning applications often rely on large datasets to be efficient, which are usually hard to gather. On top of that, restrictive cohort selection processes can drastically reduce the dataset size. Therefore, developing methods that can generalize well on small datasets could have a great clinical impact and be key in applications that only have a few amount of annotated data available. To do so, we are leveraging all patients in the dataset before any selection process. We are using both in-cohort and out-of-cohort patients, the ones rejected during the cohort selection process, in two separate tasks, one supervised and one unsupervised. The unsupervised task will not only use the in-cohort patients, but out-of-cohort patients as well. So our model can learn patterns from patients that it would otherwise not have access to. On the other hand, the supervised task will be our medical prediction task, and therefore we only use the in-cohort patients. And in more details, we have added a generative adversarial network where the generator is trying to mimic representations as close as possible to the ones produced by our transformer model from real patients, both in and out of cohorts. The discriminator then performs two tasks, differentiating the real and generated patients. This is the unsupervised task, and a supervised medical predictive task, where our model will be trained to predict certain medical outcomes. Notably, our architecture, SureGAN-BERT, leverages ideas from GAN-BERT, originally designed for NLP, and SureBERT. So we have evaluated our method by comparing it to other methods on 4 different tasks with varying dataset sizes. We can see on the top 3 rows that our model, shown here on the very last column, remains on par on larger datasets, but outperforms all of the methods tested in the lung transplant task, the last row, where we only had about 200 labeled patients. Additionally, we have performed extensive experiments in the context of few-shot learning. We have randomly removed from 99 to 50% of the training data and compared our method on other BERT-based models. We can see that as the missing percentage increases, thus reducing the size of the dataset, the gap between other methods and ours, shown by the purple line, increases as well. This shows the benefits of our method on small datasets. To conclude, we can say that the usage of both out-of-cohort patients and in-cohort patients help generalize better on small datasets without hurting the performances on larger ones. And the semi-supervised architecture forces BERT to learn better patients' representations in order to outperform the generator. I would be delighted to talk about our work further. Please come to my poster.